Welcome to an example on proof by counterexample. Earlier we proved for all integers a and b, if a plus b is odd, then a is odd or b is odd. Is the converse true? Recall, if the implication is if p then q, the converse is if q then p. The converse of the given statement is for all integers a and b, if a is odd or b is odd, then a plus b is odd. However, this is false. How do we prove this is false? We need to prove the negation of the converse is true, and therefore the converse is false. Let's look at this in terms of symbols. We can represent the converse of for all integers a and b, if a is odd or b is odd, then a plus b is odd, using the symbols shown here below. Again, we have for all integers a and b, if a is odd or b is odd, then a plus b is odd. Since this is the converse, we now need the negation of this statement and then prove that it's true to prove the converse is false. So here is the negation of the converse. Simplifying using the rules from the previous sections, we have there exists integers a and b such that a is odd or b is odd and a plus b is not odd. Let's go over this negation in more detail in the next slide. As the negation passes by the quantifiers, they change from for every to there exist, and then we negate the implication. Remember, the negation of the implication if p then q is logically equivalent to p and not q. This gives us the conjunction a is odd or b is odd and a plus b is not odd. So again, we can state the negation of the converse as there exist integers a and b such that a is odd or b is odd and a plus b is not odd. And now we know what to do. To prove that the converse is false, we need to find two integers a and b so that a is odd or b is odd, but a plus b is not odd, meaning it's even. And this is pretty easy to do because we have an or statement between a is odd or b is odd. Either a is odd, b is odd, or they're both odd. So we can let a equal 1, b equal 3, and notice 1 plus 3 is equal to 4, and 4 is not odd. This shows the negation of the converse is true and proves that the converse statement for all integers a and b, if a is odd or b is odd, then a plus b is odd is false. I hope you found this helpful.